right, coming into our next review from polynomials from Algebra 2, we're going to take a look at the remainder theorem and the factor theorem. And so those are going to be the two items that we look at in this set of notes. We're going to start with remainder theorem. This will probably be 2 videos long, so just be prepared. It might take us just a little while to review those items. All right, just going to remind you first how to do synthetic division, and I may also show you long division as well, even though we pretty much use synthetic division the most when we're doing this. So we're going to look at, typically when we do synthetic division, when you're dividing by your factor of x minus 1, that means that your 0 would have been x equal to 1, right? If you set your factor equal to 0, that would tell you what your 0 is. And when you do synthetic division, we need the 0. So we usually come over and kind of do this backwards little division symbol when we're doing synthetic division. The other thing that you want to do is you want to make sure that your polynomial, when you're looking at it, is in order from highest degree to the highest power to smallest power. So I'm going to come back in here. I'm going to reorder this to be negative 3x cubed minus 2x squared plus 2x plus 1. So that when we're writing it down in the synthetic division, it needs to be in descending order for the coefficients. So we're going to grab each coefficient and we're just going to write them in the list. So negative 3, negative 2, 2, and 1. And just leave yourself a little space. And then I like to draw a little line down at the bottom to let me know that I'm getting ready to do synthetic division. Okay, so now what we're going to do is we're going to first, step one of synthetic division is drop the first number down to the down to below the line. And then we're going to start this process where what you're going to do is you always multiply by the 1, then add to the next term, to the next term. So that's kind of the steps that we're going to do. So I'm going to go fairly quick. It's easy. I mean, it's like the easiest thing ever, just a procedure to remember. So I drop the negative 3 down. I multiply the negative 3 times 1 is negative 3, which I put it in that location. Then I add those two in the column. So it becomes negative 2 plus negative 3 is negative 5. And then just repeat. Multiply, negative 5, add, negative 3, multiply, negative 3, add, negative 2. I usually draw a line right here because what that's going to tell you is that this number right here represents the remainder, whereas this right here is the kind of the divisor, how many times it went in your quotient when you're doing this. So what we would know based on this, just kind of showing you this in like all of its entirety here. If I were to take this x minus 1 and divide it into the negative 3x cubed minus 2x squared plus 2x plus 1, it would go into it negative 3x squared minus 5x minus 3 times. And then at the very end, it's going to have a remainder of negative 2. Now, the other way, let's write these in a couple of different forms. Now, I'm just going to shrink this down to give myself enough room here. And I know it always makes my students mad when I do that because they can't do that. But all right, so what that tells me then, kind of in terms of division and what we're doing, is we were taking that negative 3x cubed minus 2x squared plus 2x plus 1. We were dividing it by our divisor, x minus 1. It goes into it an even number of times of negative 3x squared minus 5x minus 3 plus, because it's got a remainder, it doesn't go into it quote unquote evenly and returns a polynomial. It'll have a fractional part, which would be your remainder over your divisor, x minus 1. So that kind of gives us the relationship that we have when we look at the division of polynomials. Another way of looking at this is at this polynomial, negative 3x cubed minus 2x squared plus 2x plus 1 is the product of x minus 1, the negative 3x squared minus 5x minus 3 minus the 2. Now, if this had been, if it had been factorable, like if it would have factored nicely, you would not have this minus 2 remainder here at the end of it. That would have been a 0 and it would have dropped out and it would have factored nicely. But this one doesn't factor nicely, but what we've learned is that we can write it in different forms. And different things will give us different pieces of information, and there may be different reasons why we want to do this division. All right, now notice that, one of the main things that I did talk about with this one was the idea that you have to make sure that your what you're dividing it into, your dividend, okay? This part right here is kind of just notation. This is called your dividend. This is your divisor. That, of course, is your quotient, what you get after you do the dividing, with your remainder down here when we're looking at it. So that's just terminology for this. So your dividend, when you're putting it in, you do want to make sure that your dividend is in order from largest power to smallest power. Now, let's take a look at the second one right here. And again, I'm going to cheat just a little bit. You're like, I keep doing this, but you guys can zoom in on the key and look at it. I'm just going to make that really small so it's all contained in there. And y'all can zoom it back out when y'all look at it in the OneNote. Let's look at the second one. Now, the next one that's there, same idea, our 0 up here is going to be x equal to negative 2. So I'm going to come down here and I'm going to put a negative 2. Now, it's in order. Notice it goes a power of 4, a power of 2, a power of 1, and then the constant, which is technically a power of 0. Now, there's a problem here, though. You are missing a term. Right in there should be a 0x cubed, and that's important. When you're doing synthetic division, you have to make sure you put in 0 placeholders. So when I write this one out and I grab the coefficients, it's going to be 3, then 0, 1, negative 3, and 3. All right, and then you would draw the line and we would do the synthetic division. So I'm going to pause the video and I want you guys to go ahead and complete the synthetic division and then write it, and I'll enlarge this again so that we can see it. Go ahead and write it in all the different forms that you can for that down here at the bottom, and come back in and we'll see how you did on that. So I'm going to pause it and come back in a few minutes for you. Of course, it's like instant time. So you guys pause and then come back and restart it. So you're on your honor to be pausing and doing the problem. Okay, coming back in, let's see how you did. I'll zoom in just so you can kind of view that a little bit better. So kind of as you see here, put the 0 placeholder in, we dropped everything down. I mean, it's basic arithmetic here. I mean, that's all you're doing is don't make a careless arithmetic mistake when we get down here. And if I didn't mention it before, right here where we have the degree, starting out, it's x to the 4th, x cubed, x squared, x, and then the constant, right? Now notice that when you divide out one linear factor, that's where I'm getting the x cubed, x squared, x, and the constant down here. That's how I know what to put here in each of these locations, kind of as you're going down through it. Now, setting this up, both of these, you're like, well, what was the point of that? Like, really, the idea of this division is to figure out whether or not we have a 0 or not. I guess I called this a 0 earlier, but maybe I should come in here and say it's a possible 0. And what we learned in both of these cases is that these are not actually zeros or not x-intercepts, because we got a remainder here and here. So x plus 2 and x minus 1 did not divide into the polynomials evenly, which means that it is not a factor. So x plus 2 was not a factor, and the x minus 1 was not a factor. That's what we learned by doing this. Oops, sorry. I just wrote not a factor up there. So It's one of those things that you just have to we learn a lot from doing this division, and synthetic division is really an easy, quick way to check some of this stuff out. And it's also synthetic division is what you're going to do when something doesn't factor. And so that's something that comes up a lot. All right, now let's look at this last example, and this is important, and I'm going to zoom in over here for you. That the problem that we have here, and I'm going to highlight it, is that that is not in the correct form that you need for synthetic division. And so with this one, we're going to need to adjust this a little bit as we're doing it. So the zero or possible zero for this is if I take the 2x minus 1, set it equal to 0, x would equal 1/2. So that's my possible zero. Now, we can only divide by what is basically a linear factor. So when we divide, what we're actually going to do is we're going to take this and we're going to divide by x minus a half. Now, we do have to be careful because there's this extra floating 2 that's in there. We're going to have to decide what to do with that. So right now, what I want to do is I want to kind of go through and I'm going to divide that polynomial by x minus a half, and we're going to see what that looks like. All right, so I'm going to start out the process, and I'm just going to draw a line so that we're not confused there because we can kind of go off onto the side here. So my 1/2 is going to be, and it's okay not to be an integer. They don't have to be integers when we're looking at it. My coefficients, 2, 1, -13, and 6. All right, we're going to run through our synthetic division, drop your 2, multiply, add, multiply, add, -12. Half of -12 is -6, 0. Now, this is important right here. I got a 0 in the remainder position. So that possible 0, x equal to 1/2, that is an x-intercept, or 0 of 2x cubed plus x squared minus 13x plus 6. So we definitely have a 0 there. So it works out. We got a remainder. When I write this in the form, okay, now let's look at what we're doing. I could do it as 2x cubed plus x squared minus 13x plus 6. What I actually divided by was the x minus 1/2. And when I did that, it went into it evenly and gave me 2x squared plus 2x minus 12. Okay, so we could think of it that way. Sorry, I keep having myself in the way there. So I'll move that over there. Now, what we really wanted to divide by was 2x cubed plus x squared minus 13x plus 6, dividing by 2 x minus 1, which is really just dividing by another 2. And hopefully you can see that if I just divide everything by 2, I would get x squared plus x minus 6. So what that tells me in the long run is that 2x cubed plus x squared minus 13x plus 6 is going to be 2x minus 1 times x squared plus x minus 6. Those are the two factors, sorry, those are the two factors that you would have that make up that polynomial. And we can get 1, 0 from here of the 1/2. And then we could go ahead and play with that and then factor it even further if we wanted to. Like the whole point of this is for us to be able to continue and get it completely factored. So 2x minus 1, and that factors to x plus 3, x minus 2. And then basically at that point, I know all 3 x-intercepts of this polynomial by utilizing the synthetic division to help me get there. All right, now we're going to end this video right here. You're going to have an activity to do though. So you're going to do the next 5 problems, and you're going to do the synthetic division, and you're going to find the remainder, and then you're going to calculate P of 1 and P of 3, and you can use your calculator for that. So do that, come back, we'll come into part 2 of this set of notes and discuss our conclusions from these 5 problems.